Okay, this is the topic 9 math review. The first thing we're reviewing is adding fractions. So we know the rule for adding fractions when the denominators are the same is that you just add your numerators and our denominator doesn't change. So 3/12 plus 4/12 equals 7/12. And I have this nice model here of fraction blocks that I could have counted as well. And you could have drawn this. Or you could draw this, I should say, if you get a question like this. Here, 1/6 plus 2/6 plus 3/6. 1/6 plus 2/6 is 3/6, right? That's these two together. Then 3/6 more makes 6/6. Then if I look at this number line, I have 1/6. I add 2 more to get to 3/6. I add 1/6, 2/6, 3/6 more, and I get to 1 whole, or 6/6, right? It's always a good idea to simplify. If you have a fraction equal to 1 whole, we want to write it as 1 whole. All right, decomposing fractions. This is just ways of breaking up fractions using addition. So 3/5 can be written as 2/5, plus 1/5. Sorry about that. 2/5 plus 1/5. We could also do it as 1/5 plus 1/5 plus 1/5. There's really no other way to break up 3/5. You could do this in the opposite order, but that's the same thing. For 1 3/4, as soon as I see a mixed number, or really any fraction, it might be helpful to write 1 equals, and then use the denominator to tell me to tell myself what 1 whole equals in this example. So if I'm breaking this up, I'm going to break the 1 whole up as 4/4, right? I thought about that right away. And then I would have 3/4 left over. I could do this other ways. I'm not even going to show any other ways. This is the most important skill. Recognizing that 1 whole is 4/4, okay? If it asked about 2 3/4, you would maybe have to think about it a little differently, because this would be 4/4 plus 4/4 plus 3/4, or 8/4 plus 3/4. But we don't need to think about that right now. When decomposing a mixed number, what is the best way to represent the whole number as a fraction? So the whole number is represented as a fraction with the numerator and denominator being the same. All right, this question we already went over in class today on Friday. There's no correct answer here. Sorry about that, that was my mistake. So what is another way of decomposing 9/10? You could do 3/10 plus 3/10 plus 3/10. You could do 1/10 plus 3/10 plus 5/10. As long as your numerators add up to 9, you're fine, and your denominators stay 10. You're going to have a multiple choice one on the test, and it's going to be correct. So just know when you get to these, you could always add them all to see what they actually equal. So 1/10 plus 3/10 is 4/10. 4/10 plus 4/10 is 8/10. This one would be 6/3, but then you can't add this fraction, which is why this is wrong. This one's wrong because it's not equal to the 9/10 we're looking for. C would be 2/10 plus 5/10 is 7/10 plus 3/10 would equal 10/10, or 1 whole. This would be 4 plus 4 is 8/10 plus 2/10 would also be 10/10, or 1 whole. All right. What fraction can be added to the expression shown below to have a total value of 1 whole? Well, as soon as I see 1 whole, I'm thinking to myself, 1 whole in this equation equals 6/6. This step takes me 1 second and is so helpful. So 6/6 equals blank plus 2/6 plus 3/6. These together make 5/6. 5/6 plus what equals 6/6. I can just do this in my head, or I could even use inverse operations and subtract to get 1/6. My answer is 1/6. Okay. Don't forget this step. Muhammad and David are both training for a marathon. Muhammad completed 3/7 of his training run this morning and 4/7 in the afternoon. So right away, I'm going to write down the name. I probably would reread this question before I actually did this step. Right? I want to read questions 2-3 times. The first time I would just read it to get an idea. Okay, these boys are running a marathon. I know one of them ran twice, one of them ran once, and then I start writing down the numbers. Muhammad completed 3/7, and he also completed 4/7 in the afternoon. David completed 5/7 of his training run. How much more of the total training run did Muhammad complete than David? How much more? We don't really love using keywords anymore because they're not always perfect. How much more is really always subtraction, but I need to know how much more this is in total than this. So I add these first and I find out Muhammad ran his whole training run, 7/7. David ran 5/7, so to find out how much more, I subtract, and I find out he ran 2/7 more. I could also model this with a drawing. Sorry, this is kind of hard to do with one hand because I'm holding the phone, but this would be 1, 2, 3. So these are 7/7, right? These would all be colored in. And if David ran 5/7, it would look like this. And I see that he did not run these 2/7 at the end. Right, so it's 2 more, 1/7, 2/7 more.